Hello everyone, welcome back to this brand new episode of the Funtastic Academy. In this episode, we'll set a mini series based on sorting algorithms. Sorting algorithms are one of the most famous fields of algorithms to analyze. They are a building block of many modern applications and they are a good training exercise to understand how to properly find the runtime of an algorithm with big O notation. But before we dive into that, we need to answer the question from last episode, which quite conveniently relates to what even is big O notation. Last episode's quiz question was, who invented big O notation and what does the O even stand for? The answer? Well, big O notation actually has a long history. It wasn't just developed recently to analyze algorithms. It was developed back in the 1800s by German mathematicians Paul Backwin and Edmund Landau. And the O is actually a German word. It's from Ordnung, which is English for order. That's why you'll also hear people say that this algorithm is order n squared for an O of n squared algorithm. Without further delay, let's dive into this new field of sorting algorithms by passing the mic to my good friend Computer Ayush.
Thanks for that, Ayush. Now it's me here, Computer Ayush, here to explain some basic algorithms to give you an idea of how analyzing algorithms work. So, over here is everything that we did last time. We defined what algorithms are, showed an example of an algorithm from a famous book. We defined the big O notation and the RAM model of computation, and saw how we could use the two of those to come up with an accurate estimate for an algorithm's runtime. I'm going to do the same thing for two other algorithms today to give you an idea of both how sorting algorithms are made and how to analyze them. This is bubble sort. It's perhaps the simplest sorting algorithm in the world, even simpler than selection sort. Let's see how it works. Now we have an array A of size n starting at a of 1 and ending at a of n. Now, this outer loop iterates between I of 1 and n minus 1. And this inner loop goes from j of 1 to n minus I. So when the outer loop is on its first iteration, well, I is just 1. So this inner loop is j of 1 to n minus 1. When the outer loop is on second iteration, it's j equals 1 to n minus 2. Third iteration, it's j equals 1 to n minus 3, and so on and so forth. Inside the inner loop, we have an if statement, which says that if a of j is greater than a of j plus 1, if a of j is greater than the element after it, then it's in the wrong order, right? So we need to swap them. And these three lines of code inside the if statement are just swapping them. Note that this if statement is inside both the loops. These loops will iterate no matter what we do. And the if statement is just there to check if we need to do a swap. So now we can see an example of the bubble sort algorithm. N is 4. We have a 4-element array consisting of the numbers 4, 3, 1, and 2. So in the first iteration of the outer loop, we go from j equals 1 to n minus 1. So 1 till 3. And here j is 1. So we check if j of 1 is greater than j of 1 plus 1. In this case, it is. The second element is greater than the first element. And so what we do is we swap them. And then now j equals 2. So we check if j of 2 is greater than j of 3. It is also the case. So now we swap them. And finally, we check if j of 3 is greater than j of 4. We do that and we swap them. So notice how in this first iteration, the greatest element in the left has been pushed all the way back to the end. Now, in the second iteration of the outer loop, what it does is we go from j equals 1 till 2. So we check if j of 1 is again greater than j of 2. It is. And is j of 2 greater than j of 3? It is. And then we stop. So in this second iteration, we've gone from j is 1 to n minus 2. And we've pushed the second largest element to its correct position. You can sort of see how this works in the diagonals. See, this largest element is getting moved all the way to the back, and the second largest element is going all the way in this diagonal to the right position. Finally, in the last iteration of these loops, I is going from I is equal to 3, so it goes from 1 to 4 minus 3, so this iterates once. Just checking if the first element is greater than the second element. It isn't, so this list is sorted. So let's analyze the runtime of this algorithm. This is actually probably the simplest algorithm in the world to analyze. See, we have to count how many times this inner loop runs. The first time, it takes 1 till n minus 1, so n minus 1 times. The second time, it needs to take 1 till n minus 2 because I is 2, so n minus 2. And as we saw in this example, it goes all the way till I equals n minus 1 and we take 1 till 1. So this goes all the way down until we have a summation of 1. So this if statement inside this inner for loop might pass or it might fail. But that doesn't really matter. If it fails, it took 1 step to check. If it passes, it may take 4 steps to check and to do the swapping. No matter what, it's just a difference in a factor of 4. The order proportionally will stay the same. So all that we need to count is the sum of all of this. And you remember, last time we did this and we found that it's n squared minus 2 total steps. The same summation applies here, and we can say that the total number of times this inner for loop is executed is equal to n squared minus n over 2. We can just verify this is correct by checking our algorithm. N is 4, 4 squared is 16, minus 4 is 12, over 2 is 6. 6 steps. This first step that I wrote was just defining the list. It took 6 steps after that, total 7. So we can confirm that this formula is correct. And as we saw before, n squared minus n over 2, due to the biggest factor in this list, it is order of n squared. And that's another algorithm analyzed, bubble sort. Next, we'll see an actual useful practical algorithm, one that people really use to sort sets. While it might seem inefficient, you'll see that how it's actually way better in bubble sort in quite a few ways.
Thanks for that, Computer Ayush. Now let's recap what we learned today. Computer Ayush taught us about a new sorting algorithm, bubble sort, perhaps the simplest sorting algorithm in the world. We used our newfound tools to analyze the algorithm and see it has an O of n squared time complexity. We also did a trial run of the algorithm to see how it actually sorts numbers. And while doing that trial run, we noticed some significant areas of improvement. Now, in the intro of this episode, I mentioned another sorting algorithm, insertion sort, that's better and fixes these problems that bubble sort has. You'll have to wait until the next episode for me to cover that. But in the meantime, I leave you with this one quiz question. Who was the first author to use the term bubble sort to refer to this sorting algorithm? Tell me the answer, and I'll see you the next time on the next episode of the Funtastic Academy. Bye!